how to find that change in energy. Today, we are going to basically do another thing, which is very close cousin to this, but that would help us further improve our understanding. So, this topic is called the concept of relative speed of approach and relative speed of separation. Now, what you guys need to understand is that let's suppose there is mass m1, it's going to u2, u1, and then mass m2 going to u2. After the collision, they basically separate with a different velocity, as you can see. Now, what you guys need to understand is that from a single formula, we can actually make sure that we find if a collision is elastic or inelastic. For instance, if you're looking for elastic collision, then what happens is that you got a simple formula, and that formula is m equals v2 minus v1. Now this formula is effective. One second, kids. Oh, that's bad. Is it lagging for everybody? Oh, that's bad. Okay, wait a second. All right. Okay. How about now? Is it okay? Yes, kids. Is it okay or not? It's good. Okay, fine. So I was saying that basically to know that something is elastic collision or not, we can use this formula. It's very simple. U1 minus U2. So initial velocities change minus the final velocities change. If the left hand side is equal to right hand side, that means that it is an elastic collision. Now, when it comes to inelastic collision, you can use this formula, but then the left-hand side, which is u1 minus u2, will not be equal to v2 minus v1. Now, the important part in using this is that since it uses velocities, which are vectors, so direction is extremely important. Now, so when you're looking at the directions, you guys need to understand that in these equations, we do not care about the mass. And that is the beauty of it, that it will give us that answer without ever trying to know the mass. So that's it. All right, kids. For instance, if you look at this question that is underneath, it says two spheres approach each other along the same straight line. The speeds are given before collision. After the collision, the spheres separate with speed v1, v2 in the diagram shown below. All right, kids. Now what you got to do is they say which equation must be correct if the collision is perfectly elastic. If these collisions are elastic, that means first of all, you guys need to take the directions. So let's suppose if I take positive on this side, negative on this side, that means this will be positive, this will be negative, this will be positive, this will be positive. So it's really up to you what you want to do. Now, if it's elastic, then U1 minus U2 should be equal to V2 minus V1. So this is the equation. We got to remember that. Now, what you do next is that you guys need to, um, yeah, so you guys need to apply these velocities with the respective directions. For example, U1 is positive, so I'm going to write U1. Minus U2 is negative, so I'm going to put negative U2 equals to V2 is positive and even V1 is positive. So that's fine. We put it in the equation. This will give us an answer of U1 plus U2 equals to V2 minus V1. And this answer, I think, belongs somewhere here. So that means the correct answer has to be D. Now, these kind of questions, you won't be able to solve them if you forget about this equation. And that is very important to understand that this equation is crucial for these questions. Okay, kids? Any questions? Please let me know. Why? No. Why would it be positive? You just need to write, like, this is your primary equation, Alamin. You can't change what's minus and what's negative and positive in this. When you add the values, like you see, it was U1 minus U2. But when you add minus U2 here, instead of U2, you get positive. That's fine. You get it? Yeah. Very good, very good. All right. So keeping up with that, then I'm gonna do the next question. And let's see how to get that answer. So in this question, if you see, it says two spheres along the same line, velocity u1 and u2, they collide, and after collision, the velocity is v2. See, they have not talked about the mass. Why not A? Okay. Why do you think it would be A? Only U has the opposite direction. Yeah, exactly. Na? This is what we're talking about. Think about it this way. This is the real equation, right? If I write it, let's put in the values, big values. Plus u1 minus u2 equals plus v2 minus plus v1. You need to add the values in it like this. Do you get it? So what you're gonna get? You're gonna get u1 plus u2 equals to v2 minus v1. That's fine. Do you understand, Raza? Okay, very good. Hello, Tejasvi. How are you? All right. So I hope everybody understands this. And with respect to this equation, we're going to look at the next question. And I'm going to show you how important it is when it comes to the MCQ specifically. For instance, if you check out this question, it says the sphere before collision is U1, after collision it's U2, and then V1 and V2. Fair now. It says which collision is not elastic. So not elastic means you have this equation U1 minus U2 equals V2 minus V1. This is our standard equation. What you got to do, you got to put in these values with the correct signs and check which one is not equal. That's our question because it says it's not elastic. Get it, kids? So let's check it out. So for the first one, I'm going to see that it is u1 is 2, so I'm going to put 2 minus u2 is minus 5, so I'm going to put minus 5. And then if you see v2 is minus 2, and that's going to be minus and minus 5. If you check the answer, this basically becomes 2 plus 5, and that would be 7. And that is minus 2 plus 5, that is 3. Since 7 is not equal to 3, so this is one of our possible answers. Now, what you do not want to do in these questions is that do not jump to any conclusions on the first answer. Now, this has a very important thing. Please write this note here because this will help you out a lot. So I'm going to continue. I'm going to continue checking each and every part. All right. So now let's do that. Okay. Tejasvi, can you hear me? You have a working mic? Okay. Now, so kids, the next thing we're going to do is basically check the next one. So basically, according to this formula, U1 is 3 and then minus 3 equals to 6 minus 0. So it's going to be 3 plus 3 is going to be 6. That's also 6. So these are equal. So that should not be our answer because it shows elastic collision. Finally, we're going to do the next. Let's check that out. So in that one, the next one is, let's change the color. So in this one, you have 3 minus 2 equals to 6 minus 1. So you get 5 equals 5. So this is not our answer as well because on the both sides you have the same answer, right? Finally, you have the last one. Let's check that as well. So it's going to be 5 minus 2 equals to 6 minus 3. So this is going to be 3. This is going to be 3. This is also, not our answer because it's equal on both sides. So only A is the right answer in this. All right. Now you might be wondering, why am I doing this, right? Why do I have to check every part? Okay. So let me tell you why. Okay. Now in the next question, first you write this down, please. And if you have any questions, please let me know. All right. Yes. Asma, everything's okay. Alameen, Fiza, Furkan, Raza, Selma, Shazib, do you understand everything? Tejasvi. Okay. Now check the next one. All right. So the next thing that we're going to talk about is this question. Now it seems like a standard question like this because they have no mass given in it, and they're saying the particle has a speed v and it collides with the stationary particle y. So obviously the collision is perfectly elastic. So right now you should understand u1 is v and u2 is 0 because it was stationary, right? Now they say what are the speeds and direction motion of two particles after the collision? And the collision is perfectly elastic, which means U1 minus U2 should be equal to V1 minus V2 minus V1. So this has to be equal at all costs. Okay. Again, I'll start the question by taking directions. I'm going to take this side as positive. I'm going to take this side as negative. Fair enough. What you do next? What you do next is you start applying. On this side, U1, you will take this as positive, and Everything to the right, just write positive on it. Positive, positive. Left is negative, positive, negative, and stationary is zero, so it doesn't have any particular direction. Anyhow, so U1 is V minus zero. V2 is this one. So this is V2 and this is V1. So V2 is V and minus zero. So if you see, you get V equals V. Now, if I were you, I would not settle on this answer because it shows that it is elastic. So this could be one of our answers. Now, any person who checks this might end up getting it wrong. So let's check the other ones. Now we go to the next. We'll see that this is V minus zero equals to V2 to the right. So this is this minus V2 to the left. So what you get, V equals zero. So obviously it shows that it is inelastic, which means this is wrong. Now comes to the next. This one is V minus zero equals 2. Now V2 is V over 2 minus, and this is minus V over 2. So what you get V equals to V, which means that this answer is also showing me the right elastic solution. All right, kids. So now we have two correct answers. That is why I'm telling you not to settle on the first answer you find. Okay. Now check D. In D, you have V minus 0 initially. Then V2 is 0 minus V because it goes to the left. So you can see it is also V equals to V, which means this is also a correct answer according to our equation. Now we got three correct answers and one wrong answer. What to do now? All right. So let's write this important note here so that you do not make a mistake. If there are multiple correct answers, apply law of conservation of momentum. Because no matter what, every collision must actually follow this particular law. Otherwise, it cannot happen. That is our basis, right? So now let's write the law of conservation of momentum. So law of conservation momentum says m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. This is what it says. Okay, now let's check it out. Here, honey बिल्कुल कम डालना. Okay, now what you gotta do is let's check it out. So basically they said that basically particle X and Y are identical particles. Identical particles means that we can both say that they have the same mass. So let's call them M. Doesn't really matter. So I'm going to write M, and then initial velocity was V. This was M, and initial velocity was 0. I'm checking this for A. Okay. Then the next one is M, and the velocity was 0. And this one was M, velocity was plus V to the right. So what you get mv equals mv. So momentum is conserved, which means probably this is my answer. Get it, kids? All right. Now, sometimes we are lucky right now. We're lucky because we got the first answer is the right one. But then sometimes, Lucky answer, but you see, sometimes the answer can be D as well, right? So if that is the case, we got to check, right? So for just, our own understanding, let's check the other ones as well. So for C, because B is absolutely correct, you don't want to check it because it's absolutely inelastic. So for C, let's check it out. So it's going to be MV minus M times 0. Then U1 was M times minus V2. And this one was plus M times plus V2, right? Or just write V2, it's okay. So that means if you check it out, it will be MV. This will be minus MV divided by 2. This will be plus MV divided by 2. So it's basically 0. So it does not conserve momentum. So that cannot be your answer. Similarly, if you check G, it would give you something like this as well. MV minus M times 0 equals to M times minus V, and that's plus M times 0. If you check, the answer comes as MV equals to minus MV. Again, minus is it should be conserved. It's not. So that means D is also incorrect. Okay, kids. So speaking of that, then you can write this down. This is so important. And then we shall go forward. And give me 1 minute. All right, kids. So I hope you guys understand that. Now, let's go to the next. So now this question, I think you guys will are fully equipped to do these sort of questions. So I'm going to give you this as homework. So you can try this on your own. And let's see, this one as well, homework. Very similar questions, nothing really big. Homework as well. Same, homework. So whenever you have a lot of homework of a particular topic, that means the topic is something that comes very frequently. So take that seriously as well. Anyway, which one? This one? This? Okay. How about you try this and then we shall discuss if you can't do it now. What do you say, Alami? All right. Get it, kids? Should I go forward, please? Okay. So it's okay, let me try it. Try. Just try. Just try. If you still don't do it, we can do it tomorrow. No worries. All right. Anyway, so going towards now the two-dimensional momentum. Now, for two-dimensional momentum, I just want to basically start off with a very important part here. Whenever you see momentum in like different directions or certain angles, just remember tip number one is to break momentum into horizontal and vertical directions. Then apply the law of conservation of momentum in both the directions separately. All right, kids? Now, now let's check out this question. In this question, it says the two objects, one is going at this velocity, x, and y is going at 60 degrees from the horizontal at this velocity, right? Then they say when they hit, they are now going together in the vertical direction. Everybody understand the question? Okay. Now, they say by considering the components of momentum in direction from A to B, so A to B means horizontal direction they want to, they want you to find the momentum in. Show that the ball X has a mass of 4 kilograms, whereas Y has a mass of this. We're going to find mass of X. We don't know that. Mass of Y is 2.5. Do you guys agree? Everybody understands that? Now, the first thing I would do is to, if I were you, I would create the components. How would I do that? I'm going to basically put it like this. I'm going to put it like this. And this 60 degrees is this 60 degrees as well, because these are corresponding angles, which means this is going to be 9.6 sine of 60, and this is going to be 9.6 cosine of 60. If somebody has a question how I did this, please let me know. Hmm, cool. Now what you gotta do is that you got to take the directions. So I'm going to take this direction as positive. I'm going to take this direction as negative. We'll be looking at the whole thing in the horizontal plane right now. This will be positive. This will be negative. These are opposite. We're completely going to ignore this because this is vertical. We don't need it right now. Okay. Afterwards, what happens is when they collide, there's nothing going in the vertical direction, which means momentum in horizontal after collision is 0, right? So I'm going to write the equation now. The equation is the same, m1u1 plus m2u2 equals m1v1 plus m2v2. Get it, kids? Any questions here? How to tell what is cosine and what is sine? Very easy. When you draw the vectors, right, you should understand that this angle that you have touches the original vector and touches one of those components. Do you understand, Rudra? The vector or the component the angle touches is the cosine one, and the vector that it doesn't touch is the sine one. It is as simple as this. Get it? All right. Now we have written the equation. We're just going to see it in the horizontal direction. So let's check it out. So M1, we want to find mass of, and the speed initially was 3. So I'm going to write 3. M2 is 2.5, as they've given it here, and the speed horizontal is minus 9.6 cosine 60. Interestingly, afterwards, what happens is that they both go vertically, so the momentum has to be 0 here. So I'm going to put 0 right here. Yes, Salma. Yes, Salma. Go on, please.
सॉरी सॉरी सर आपने 9.6 cos 60 क्यों लिया है?
Okay, this is horizontal. We're looking at horizontal only. They've said in the question, by considering components of momentum in the direction from A to B, which is the horizontal direction.
Okay, got it.
Do you understand? Yeah.
Mhm.
And why I have taken after collision completely 0? Because if you see, let me write, because none of these, because none of the two vectors are horizontal. They're going vertically. Do you understand? That's why I'm taking like that. Anyway, when you solve this is going to be 3m. This is going to be minus 12 equals 0. 12 will go there. So this will be 12. M will be 12 divided by 3. That's going to be 4.0 kilograms. Hence shown. Okay, kids. Any questions now? Okay, cool. Asma, everything is clear. Fiza, come on time, please. Furkan, what about you? Shazib? Okay. Pretty good, pretty good. All right, now let's go to the next part. In the next part, it says calculate the common speed of the two balls after the collision. So they're saying calculate this speed. Okay. First question you should ask yourself is what is the direction? Is it vertical or is it horizontal? Now, obviously, as you can see, it is going upwards. That makes it vertical, right? So now we need to take momentum conservation in vertical direction. This is what you could take now. All right. So it depends on what they're asking. You got to understand that. Now apply the same formula. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. What you do next is initially, if you see this vector X was never vertical. So that means if I take this direction as positive and this direction negative, so the 4 kg mass has no vertical speed. So I'm going to put 0 here. However, the 2.5 kg mass did have a vertical uh, component, and that was 9.6 sine 60. So I'm going to take it positive because I've just signed a sine. So which means 2.5 times 9.6 sine of 60. Afterwards, they stick together. So this is the case 2. When two objects stick together, their masses are added up. So I'm going to add the masses now. 4 plus 2.5. And then the speed is the common speed they have that we need to find. Now, this will be 0. This will be 20.78. This will be 6.5 V. So V then will be equal to 20.78 divided by 6.5. That comes out to be 3.2 meters per second. You can check, please. And if you have any questions, you did not understand something, let me know here. Yes, isn't it the same? Can't you see?
Sir, nahi, like
This is the
part A.
part A. Okay, here you go. Part A required me to find everything horizontal, so I took every vector in the horizontal. Part B required me to find everything in the vertical, so I took everything that was in vertical. Understood?
सर लाइक लेकिन कोलाइड करने के बाद हर चीज तो वर्टिकली ट्रेवल कर रही थी तो हमने V2 0 क्यों कंसिडर किया है
Where?
लाइक पार्ट ए में
Part A में क्यों zero किया? Because I told you this is the equation in the horizontal direction. If both of them after colliding were vertical, then they do not have any horizontal direction. So that's why they should be zero.
हम्म
So what I wrote in the first place was that you have to break momentum into horizontal vertical direction and then apply law of conservation momentum in both the directions separately. So the equation that we used here only caters to this direction, and the equation that we have used here only caters to this direction. This is why, if you see, afterwards both are vertical. I took 0 here because there is no horizontal component of that. And in this one, I took U1 as 0 because the 4 kg mass X was moving horizontally initially. So it does not have anything vertical. That's why. Do you understand? It does not have vertical speed at all.
यस
So please have a look at it. Try to absorb it. If you still don't understand something, let me know so I can explain that point again. Okay. All right, kids. Now going to the next, right? In the next question, it says, determine the difference between the initial kinetic energy of ball X and the kinetic energy of and initial kinetic energy of ball Y. Well, that's fine because kinetic energy is just a scalar quantities. It doesn't really care about directions at all. So initially, if you saw X, which was 4 kgs, was going in the horizontal direction at a speed of 3 meters per second. I hope that was 3. Yep. And Y, which was, oh, and Y, which was going this way at 60 degrees at 9.6 meters per second, was of 2.5 kg. So we want to find the difference of this, the kinetic energies initially. So initial kinetic energy of X would be half mv squared, which can be written as half times 4 times 3.0 whole square. That should come out to be 18 joules. Then initial kinetic energy of Y got to be half times mv squared. So it's going to be half times 2.5 times 9.6 whole square. So that's going to be 115.2 joules. You subtract these because you're going to find the change in energy. So 115.2 minus 18 would give you something like 97.2 joules. Now, you can write 97.2 joules because all our readings were in two significant figures, so we can write in one more. But you can also write it as 92 joules. More than that would be wrong. Less than 92 would be wrong as well. Okay, kids? Yes, Furkan, do you understand everything? And Shazib,
सर
wake up,
97
please.
जूल्स नहीं होगा?
Hmm?
97 जूल्स नहीं होगा?
नहीं 97.2 भी हो सकता ना because you can take the minimum significant figure in data or one more than that. So the minimum are two, so you can write it in either two or three. It's all right.
सर आपने ऊपर 92 जूल्स और 97.2 जूल्स लिखा है।
Oh, my bad. Why did I do this? It has to be 97. Okay, fine. Is it okay
Yeah.
now?
Yep.
Furkan, wake up, please. Why are you sleeping in the class? That's not allowed. Okay, so now that you guys have done this, we could basically uh, try this question, and this is just a question of vectors. You have learned the vectors already. So basically, what they're saying is that initially two objects collided like this, and when they collided, they went uh, in these two directions. Okay, so what would be the vector diagram? It's just like head to tail rule, right? If you basically see that this is the momentum of the first particle, right? Afterwards, and the sum of this would be like this. So this vector that I've just drawn is basically m times u by 2. Why do I draw it like this? Because you guys need to understand that um, you got to do head to tail rule because when you add vectors, you add them by head to tail rule. So I have basically picked this vector and placed it right here. Now, the result, the sum of these has to be equal to momentum before, which is actually a straight line, and that is mu plus m times 0, like that, right? Which is, it was stationary, that's fine. It would be mu like this. So we got to find the right thing here. So m times u by 3 should be at alpha angle. So let's check it out where it is. It looks like this one seems okay to me because it is in the same direction as shown in the diagram. Even this one seems okay to me as well. But I'm not going to pick this one. Why I'm not going to pick this one? Because you see, this angle is alpha, which should be the same angle alpha if we draw it this way. So alpha is here, beta is here, so that's wrong. These two are wrong because mu over 3 is shown in this direction, which is clearly wrong as it was shown in this direction in the diagram, so that's wrong. Same goes for this one, wrong direction for that. So then we're gonna recheck other ones. Mu by 2 was at beta, this is beta, and it was downwards like this, so that's fine. And mu is also towards the right, so and this makes a perfectly right vector triangle, so this has to be the correct answer. Is it clear, kids? All right. So now it's time for let's see what you get for the next one. So this one is pretty simple, like just like you need to do make horizontal and vertical equation. I'm going to leave this as homework for you. You can try this. And then for this one, I think it's almost the same question that we just did. So this one as homework, but obviously you can discuss it if you feel any difficulty in any of these, and I will be able to help you here. In any case, I will try to solve this one. Okay, so just to do it once more. Okay. Um, and then we'll move to the next topic. All right, kids? Okay, now check this out, please. In this question, it says a ball of 0.2 kg traveling in x direction at a speed of 0.50 meters per second collides with a ball of this mass traveling in the y direction at a speed of this, as you guys can see. It says two balls stick together. So this is obviously classic case two. After the collision and traveling at an angle theta to this direction, as you can see. All right, kids. So they say, what is the value of theta? And interestingly, when they stick together, they have not actually given any, speed here. So let's assume that it has a speed v later on. Okay. Now the first thing is that because this is a two-dimensional momentum question, we got to separate these two into uh, horizontal and vertical first. So I'm going to do that. I'm going to do this as horizontal. So it's going to be V cosine theta for this next angle, and this one will be V sine theta because it's not next angle. I'm going to take this direction as positive. I'm going to take this direction as positive. I'm going to take this direction as negative. I'm going to take this direction as negative as well. You guys get it? Okay. Once you've done this, now what you got to do is you got to make two separate equations. So let's do that. First of all, we're going to make equation for horizontal, and then we're going to make an equation for vertical. For horizontal, I'm going to say that it's going to be m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So m1 here is 0.20 and the speed horizontally it was 0.5, so I'm going to write 0.50. M2 was 0.30, but it was completely vertical, so I'm going to put it as 0 because it doesn't have any horizontal speed. Later on, M1 and M2 combine, so we're going to add the masses together. So it's going to be 0.20 plus 0.40, and horizontally, their speed is this one. So V cosine of theta. You guys agree with that? Okay, very good. Now, this means that this is going to be zero point 0.1 and this is going to be 0. This is going to be 0.5 V cosine theta, like that. So could you repeat why V1 is 0? Yes, U1. You means why this one is 0. This is what you want to ask? Because look at this object. Where is it going? Vertically or horizontally? Okay. Vertical. It is vertical, so it means we are looking at only horizontal direction. So it means it doesn't have any horizontal velocity. That's why I've taken it 0. Understood? Okay, good. Now, this means this will be 0.1 divided by 0.5. So V cosine theta is going to be somewhat like, what that might be, I don't know. Let's just keep it like this. I don't know. So, or we could just further resolve this. 0.1 divided by 0.5. Oh my God, that's okay. So it's going to be 0.2. So 0.2 equals to V cosine theta. So we're going to put it as first equation. So difficult question, doesn't matter. Now, once we have done the horizontal, we can move towards the vertical. So let's check it out. We're going to write the same equation, m1u1 plus m2u2 equals to basically m1v1 plus m2v2. Now check this out, kids. Because we're only looking at vertical, and as you can see, the first object, which was 0.20, was basically 0. Why? Why am I taking it 0? Because it was completely horizontal. It doesn't have any vertical speed or component. Then the next one will be 0.30, and the speed was 0.40 downwards. I'm taking positive, equals to, after that, they both combine. So 0.20 plus 0.30. And in the vertical direction, they have this speed. So I'm going to use V sine theta. All right, kids? Now, very nice. Now, the next thing is this will be 0. This will be somewhat like 0.12. This will be 0.50 times V, like that. V then will be 0.10, sorry, sine theta. This will be 0.1 over 0.50 equals V sine theta. So let's check it out now. This will be 0.24 equals to V sine theta. This is our second equation that we got to do. All right. Anyhow, now that we have found the two equations, we can, there are two things that we need. We need theta only, don't need V. So what we're going to do is write 0.24, or you can do it here. So V can be written as 0.2 divided by cosine theta, and we will replace this right here. If I do that, then what you get? 0.24 equals to, instead of V, I'm going to write 0.2 cosine theta times sine theta. So I've just replaced V here. Now, check this out, please. If you see what has happened here is we have 0.24 equals to 0.2 times, we know that sine theta over cosine theta is equivalent to tan theta. So we can write tan theta here, and then we can solve this. So 0.24 divided by 0.2, and then shift tan inverse of the answer. So I get theta as 50.2 degrees, and that is this answer. All right, kids, any questions now? Please let me know. Okay, now you see something very, very important. In the paper two question that we just did for the two-dimensional momentum, it took less time than this paper one question that we have just done now. Okay, so in paper one, you will find certain very difficult questions. If they're not difficult, they will be long. Okay, so let's suppose they've asked you about a fact. Okay, so they say state Newton's third law. Okay, so now that's a fact. You read the statement, you can actually do that MCQ in less than 10 seconds. Now you got to allocate the saved time into questions like these. Because if you don't, you will end up not finishing the paper. Okay, so the paper is back and forth, and you guys need to spend very less time on the fact questions and more time on uh, equation questions like these. All right. So just a tip for you, if you when you're practicing topical papers, you guys need to keep that in mind. All right. Any questions now? Please let me know. Okay. All right, kids. So let's check it out now. Okay. So we've finished this chapter now. It's a good thing that we finished early. Now it gives you this time. I'm going to create an assignment for this one. I want you guys to complete this um, and submit the work. Okay. So, oh my God, that's not fair. That's not fair. How did I? Okay, I know how to. Minimize, please. Okay. So I'm gonna add the assignment till here. So you gotta do now submit all homework questions till page. I think this page that we're talking about is 148. 148. All right. So this is your assignment for today. Please make sure you do it. And inshallah, when we see each other tomorrow, we are gonna then um, try to finish the other chapter as well. So have a nice day then. Bye.